very good morning, good afternoon, good evening to all the participants, candidates and my friends for this NPTEL MOOC course, the title of which is Application of Forecasting, Regression and Time Series Models, and my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, this course covers three broad topics: forecasting, second one is regression, third one is time series. And as you can recollect, we are slowly going into depth about regression models. And regression models we have been discussing for the last two classes. So, this is week 6, 27th lecture which is going on, and we will discussing examples of regression. So, enough of discussion of theory, enough of trying to draw the diagrams and explain it. So, we will now slowly go into the problem solving. Again, as I said, problems will be solved using simple Excel sheet, not much of a problem for anyone. So, now before we solve the problem, a simple idea to be discussed. So, if you remember, in the models when we were discussing talking about multiple linear regression, talking about simple linear regression, drawing the error, what the error means, trying to basically give the idea of mean absolute error, mean error, sum of the squares of the errors, and similarly you can consider all the other error time concept which you have considered in forecasting. Now, whether in forecasting or in area of regression, the idea is always to minimize the error. Make it theoretically 0 if possible, but if not, try to basically that error, because errors, different errors may give you different answers. Remember that. Consider that error, or consider the values of the model, and what is the values of the model which is chosen. I will come to that within few minutes. The values of the parameters or some symbols in the models are chosen in such a way that the error is minimized, because utilizing those parameters or those variables or those symbols of to depict who in the future models will give you the error to the minimum possible extent. Now, what was the idea? The idea was to minimize the error. And if you remember, I did also mention when I was doing the explanation using the diagrams, that y is the actual value as in forecasting, y hat is the forecasted value or the predicted value, which was f in the forecasting case. So, I will use the color here to depict. So, I will use, say for example, dark red to basically denote y, actual value. We have corresponding to that, we have the x's, and considering the x's are, for the time being, I will use the very generic symbol. As we come back to the slide, everything will be crystal clear. Consider you have x1 to xk. There are k number of random variables which are independent, which will help us to find out the dependent variable, and also assume that the error is, which is denoted by epsilon. So, there are n number of readings for y, n number of readings for x1, and obviously there are more than, so there is x2, x3, x4, so on and so forth. There are n number of readings for x2. Similarly, finally, there are n number of readings for xk, and correspondingly the error is also n in number, because for each x set of x, x1 to xk, you have y and you have error. So, that may be the first reading. Similarly, for the second reading, y2 actual value, x1, if the first suffix denotes the random variable number and the second number denotes the reading number. So, it will be x12, which is the second reading of the first random variable. Then you have x22, which is the second reading for the second random variable. Similarly, you have xk2, which is the second reading for the kth random variable, and you have epsilon 2. Similarly, we will go for the nth reading. Now, when you use the model, if you remember, the regression model is basically a simple linear regression. So, in the case when I am trying to denote the linear regression model, I will use the black color to denote it. So, you will basically have y is given, and if you remember, I did mention that simple equation y is equal to mx plus c, that will make sense immediately within few minutes. So, for the multiple linear regression case, you will have a constant term beta naught, and what is beta naught you will understand, plus the parameter beta 1 into x 1, which is the beta 1 will give you the rate of change of x 1 with respect to y, given x 2 to x k are constant, which I mentioned in the last class. Similarly, for the last term, it will be beta k into x k, where beta k is the rate of change or regression coefficient, as you can say, the rate of change of x k of y with respect to x k change, provided x 1 to x k minus 1 are constant, and plus you have the error term. Now, if you see this model carefully, y values are all known because they are given to you from the data. x11 to x1k, that means all the n readings for the first random variable are all known. Similarly, x21 to x2k, which is the reading for all the second random variable, is all known. Similarly, if you go to the kth one, xk1 to xkn are all known. And also the fact is that you do not have the error, but you want to minimize the error. Now, what things are unknown here? Obviously, error is not under your control, but what you want to find out are the parameters beta, which I will just mark in say for example green. So, beta naught is not known, beta 1 is not known, similarly till beta k is not known. So, I want to find out beta naught, beta 1 till beta k in such a way that I am able to minimize the error, or I am able to minimize the sum of the square of the errors. So, once I basically find out beta naught to beta k, they are basically considered the estimate, because if I knew the actual values of betas, then obviously the errors I would basically use the best betas, then obviously the value of error would technically be 0 theoretically if I am aware of the population or the actual values of betas. As I am not aware of the actual values of beta, I use the estimate, and I need to find out the estimate. How I need to find out the estimate? By that, because the error term would be given by this. Let me use the blue color. The error would be this error, and this black epsilon and the blue epsilon the same, the error. Error would be given by, ith error is given by yi, which is the ith reading for the actual value of y, minus yi hat, which is the predicted value. So, if I want the error for each term, it will be I is equal to 1 to n, because there are n number of readings. If I want to square the error, I need to basically square this term. If I need to find out the sum, I need to find out the sum of these errors. And this is the error, sum of the square of the errors we want to minimize. And that is the concept of the sum of the squares, or the mean squared concept, which will be the basic framework for the regression concept. Now, having said the storyline, I will come back to the regression model in some details, where matrix connotation will be utilized, but do not be bothered about that. Only be bothered about the final result which we will be utilizing, even though in the slides the deductions will be given, but do not be bothered about proving it. I will just mention the steps. So, before I come to the multiple linear regression, let us solve the problem, this same idea using the simple linear regression, where there is only one x. So, whatever I have explained, I will erase the writing and then slowly go back into the slide which explains step by step whatever I did mention for the last 5-6 minutes. So, here is the simple linear regression model. I will use the dark red color. So, you have yi is equal to beta naught, which is a constant, into beta 1 into xi, because there is only one x. So, obviously, I am not adding any suffix to x, plus the epsilon and I is equal to 1 to n. So, actually if I write the equation using the same red color, so I will have y1, which is the first reading of y, will be equal to beta naught plus beta 1 into x1 plus epsilon 1, which I will try to denote the error in a different color, because it will be easy for me to talk then. So, this is the error term, and this error is marked in blue, this epsilon 1 first. Then if I have the second reading y2 is equal to beta naught, because beta naught remains same, what we want to find out, plus beta 1 into, this is the second reading, which will be denoted by x2. So, this suffix is the reading number, do not worry, it is not the random variable number, plus you have error 2. I continue doing this, go for n reading. So, the last reading would be yn, nth reading is equal to beta naught, which you want to find out, plus beta 1, which you want to find out, into xn. This is the reading number for the x random variable, plus I have error n. And this is the set of errors which are marked in blue, which I want to basically minimize. And this is the basic framework of the story which I am talking for the last 10 minutes. Now, what we do is this, as I mentioned, I want to basically find out the sum of the squares of the errors, minimize it. So, here is the sum of the errors. So, if you see here, this epsilon square is basically the square, and I am trying to find out the errors. So, that is basically sum of the square of the errors. So, if I write the sum of the square of the errors, what are the variables which are unknown? Beta naught and beta 1. So, if I want to basically minimize the error, I need to basically differentiate partially. Remember, I did mention time and again, beta 1 is basically, for this case it is simple to understand, beta 1 is the rate of change of y with respect to x, considering all other things are constant. So, if I basically consider there are two random variables, parameters to find out, so that would be beta naught and beta 1. So, I need to basically partially differentiate the sum of the squares of the errors with respect to beta 1 and beta naught respectively. So, there should be a summation here. I will do the needful in the slide, so there is no error or no confusion. So, when I basically write down the error is what? The actual value, which I will mark in dark, to put a tick mark in dark red, minus, so obviously the minus sign would be there for beta naught and beta 1, and considering that I differentiate and put to 0. So, once I put to 0, I obviously you can do the second derivative and check that is coming to the minimum value. So, once I do that, I have two equations means there are two beta values, beta naught and beta 1. When I put them in the equation, solve it, I have the actual estimate of beta hat naught hat, which is given by this equation, which I will mark in light green. Similarly, when I solve it, I have this equation for which is for beta 1, which I will mark in light green. So, these are the equations, do not be bothered about the derivation, double check that. So, once I have these data points, I can find out beta hat for naught, beta hat for 1, and solve it and utilize these beta hat values for the subsequent calculation. Now, the question may be that what happens if there are more than 2x? You will basically utilize the same concept. Find out the sum of the square of the errors, differentiate with respect to ones with beta naught, partial differentiate with respect to partial differentiate with respect to beta 1, then partially differentiate with respect to beta 2, considering there are 2x, one is x1 and x2, and then you have 3 equations, 3 unknowns. What are the 3 unknowns? Beta naught, beta 1, beta 2, solve them and get that equation. So, given the simple linear regression model, the two parameters of beta hat naught and beta hat 1 are given, and we will utilize that these values to solve a problem now. So, this is the problem which we have. So, what is the background on the problem? So, consider the example below where we have 20 data points regarding hydrocarbon percentage, which is the x variable, which is the independent one. Based on that, the purity of oxygen in percentage, which is y, is given, and we need to find out what is the relationship between x and y. So, here the first row which I am marking in green, the third row which I am marking in green are the purity of x, which is basically y, which is the dependent variable, and the corresponding second row and the fourth row are the hydrocarbon percentage, which is x, which is the independent variable. So, you have the first and the third as the dependent variable and the second and the fourth as the independent variable, where values are given. Now, let us basically try to solve it. So, let us do it simultaneously with the Excel sheet if it is possible. So, that means that results are given if it is possible, in the sense that we will start, and if there is a spillover we will go to the next problem, or try to wrap up in this lecture only. Okay. Now, we will copy this diagram and this value, sorry, here it is. I already have, so it is easier for us to denote. So, if you consider, by the way, the Excel sheet which you see, if it is visible, so it has got 4 sheets: distribution, which I mentioned, forecasting, regression, time series. I am trying to basically keep all the information in one Excel sheet, but when the Excel sheet will be shared with you, because after the forecasting one is shared, you will basically have only the information related to the forecasting, and once the regression model starts, only the Excel sheet related to the regression part will be done, and similarly for the time series. Why? Because I do not want any confusion to be there amongst any of the participants and the candidates for this course. So, now this is the simple linear regression of hydrocarbon with versus purity of oxygen, and along this axis which we have plotted, which is basically the value of x, are denoted along the column A. Column A is this one. So, I will just zoom in a little bit more. So, you can, so these are the values. So, if you see it, the values are basically starting from 0.99, then 1.02. So, you have the values here 0.99, 1.02, and the number of data points, if you can recollect, it was given by 20 as it is given here. And the value purity of oxygen is given in the next column, which is column B, and that corresponds to the values as given here. So, the value was, first value was 90.1, next was 89.05, the values are here 90.1, 89.05. So, now I need to do the calculation. I will, for the time being, erase this graph, because the graph will be coming up later on. So, what is the equation we have? We have n is equal to 20. So, in the value of the corresponding case of, if you see, beta naught is equal to average value of y, which is summation of yi divided by n, minus beta 1 hat multiplied by again average value of x. Average value is y bar, average value of x is x bar. While if I come to beta 1 hat, you have basically the sum of the square. S means sum of the squares of x and y, and sum of the squares of x with itself, and the value, if I basically expand, is this. So, you can basically check in any book, but I have only given the final answer here. So, if you can utilize this, which means that you are trying to basically sum it up of all the difference between xi and x bar whole square multiplied by y, and in the denominator you will basically have the values of xi bar whole square, square. So, when I basically simplify it, this is the formula, and I will utilize that. So, let me basically take the values accordingly. So, I would have average of x. So, I will basically mark it in yellow, then basically I have the average of y, which I also mark in yellow. So, is 1.196, 92.167. So, let us go back to the slide. So, if you see n was 20, the average value of x bar was 1.196, which you have found out. Similarly, you have value of y bar is given as 92.160, you have found out 90.1605, consider is 16, 2 decimals is fine. Now, you need to find out in the formula, if you go back, you need to find out these. First is xi into yi, multiplied, sum them up. So, let us go one by one. So, I will basically in column number C multiply xi and yi. So, these are the values. And what do I do? If I see this one, the first term on the right hand side equation on the numerator is xi into yi, sum them up. So, when if I sum them up, so remember this yellow one on the average, and this is the sum in for the C column is the sum. So, obviously, I will not be utilizing the yellow color. What I mean by not utilizing the yellow color is this. So, this would be marked as light green because there is a sum. So, let us see the sum value is given as 2214.74. So, this is 2214.75, 2 places of decimal. So, if I go to the next value which is needed to be found out is summation of xi multiplied by summation of yi. So, summation of xi basically I can find out using the green color, which is just sum of x. That yellow one was the average. And the sum of y, so I will mark it in green because the sum was all given in green. So, the sum of x is 23.97. So, sum of x is coming out to be 23.92. Yes, here it is 23.92, and sum of y comes out to be 1843, which is 1843. So, all the values are matching. Now, if I go back to the formula, you have to divide by n, and so the numerator part all the calculations are done. So, n is 20, we will find it out. Now, in the denominator what we need to find out are two terms. One is sum of the squares of x. So, sum of the squares of x are these. So, this is x multiplied by itself is gives you the square. I copy it. So, I need to find out the sum of the squares. Square concept is basically given by the green color. So, this is the sum of the squares 29.2892. So, if I go back to this calculation, the value of the sum of the squares comes out to 29.2892 as it is given. So, if I now go back to the other formula, so I am switching between the Excel sheet and the PPT slide. So, you will have both, so do not worry. So, if I go to the last term which is there in the denominator is square of the sum of x. The square of the sum of the x already have. So, the square of the sum is this. It comes out to be 572. I will mark in say for example a different color as say for example light pink. So, this is 572. So, let us check the value where this 572 is there. You have 572 which is the square of the sum of x. So, all the values which are shown in this slide have been easily calculated and found out using the Excel sheet. So, once this is done, I put them in the value. So, I put them in the value means I utilize the last equation and the second last equation to find out beta 1 hat and beta naught hat, which I put, and I basically find it in this equation where beta 1 hat comes out to be 14.92. So, what is beta 1 hat is basically the rate of change of y with respect to rate of change of x, and if you remember, x was the hydrocarbon and y was basically the oxygen percent, all both in percentage. So, for 1 unit change in x, the rate of change of y comes out to be 14.92 units. And what is beta naught? Beta naught is basically, if you remember the equation, y is equal to mx plus c. C was basically the intercept in the y axis. So, the intercept comes out to be 74.315. So, the equations we have already solved. Now, let us plot it. If we remember, I had removed the diagram in the Excel sheet. So, if I plot it, the plot values are column A and column B. So, these are the values which I have. So, purity of oxygen is Y, in the x axis you have basically hydrocarbon. So, the values are ranging from 0.8 to about 1.6. So, let me make it this x axis smaller. So, it is coming from 0.8 for better visibility to 1.6, and if I see the x axis is basically between 86 to 100 maximum. So, I basically can decrease it to 100. So, this is the plot. Now, if I want to put the best fit line at the trend line here, and is the linear line. So, this is the linear line. If I want to put the linear in equation, and with the equation, give me 1 minute, display the equation on chart. So, this is the one, and if I have that equation, if you pay close attention to it, I marked in saved example red, bold, the equation comes out to be 14.92 and 74.32, and the equations values which you have used is 14.92 for beta 1 hat and 74.32 for the intercept. So, intercept is basically where it cuts this. So, the equation which you have solved with the values, with the data, and the plot which we did using the Excel sheet are exactly matching. So, you can basically use the Excel sheet, plot the diagram, but be aware the stepwise calculation which we do for a simple linear regression. So, the data which is given for simple linear regression, we will solve it different type of problems time and again. So, hope it is clear, and we will continue the discussion in the concept of simple linear regression and multiple linear regression. Have a nice day, and thank you very much.